Hello dear friends, welcome my channels. Today's discussions is ordinary differential equations. So friends, the number of regular singular points of the differential equations x minus 1 whole square sin x y double dash cos x sin x minus 1 y dash plus x minus y equals to 0 in the interval 0 comma pi by 2. So friends, what is given? My given equations, I first write x minus 1 whole square sin x y double dash cos x sin x minus 1 y dash plus x minus 1 into y equals to 0. So friends, I just considering this equation like this. Y double dash plus px y plus q equals to 0. So friends, px in here cos x into sin x minus 1 divided by x minus 1 whole square sin x, and qx equals to x minus 1 divided by x minus 1 whole square sin x. So friends, in both p and q, singular point is point is 1 and 0, and you will see that limit x tends to 1 px equals to infinity, and limit x tends to 1 qx equals to infinity. So friends, everywhere and x tends to 0, you can get that 0 and 1 both are singular points. So singular point are 0 and 1, and now we have to check that it is regular singular point or not. And similarly, limit x tends to 0 px tends to infinity, and limit x tends to 0 qx tends to infinity. So I have to check now. I have to check it is regular or not, because my question is regular singular point, not singular points, regular singular points. Now I have to check. Now check p 0 and 1 are regular singular or not, regular singular point or not. So friends, how can I solve this? Limit x tends to 1 x minus 1 px equals to limit x tends to 1 x minus 1, what is the px value, friends? You will see px value is cos x. This is my px value. So this value is x minus 1 cos x into sine x minus 1 divided by x minus 1 whole square sine x, and that implies limit x tends to 1 cos x by sine x and limit x tends to 1 sine x minus 1 divided by x minus 1 equals to cot 1. So it is finite value, friends. Now again I have to check limit x tends to 1 x minus 1 whole square qx equals to limit x tends to 1, whatever I get, x minus 1 is equal to x minus 1 divided by sine x. This value equals to this, and this value equals to 0. So it is finite value. Similarly, friends, limit, now I check that it is x equals to, so x equals to 8 at x equals to 1, it is regular singular point. Similarly, when I take limit x tends to 0 qx into x square, qx into x square, so whatever I get, qx value is equals to x square limit x tends to 0 limit x tends to 0 1 by x minus 1 sine x. So this value is x limit x minus 1 limit x tends to 0 x divided by sine x, and that value is zero, finite value, and limit x tends to 0 x into px equals to whatever I get, limit x tends to x into px, px value is sin x by x is equal to 1 x into cos x, limit x tends to 0 cos x and sin x minus 1 x minus 1 divided by x minus 1 whole square sin x, and that value is, this value is 1, and another value is 1 into sine minus 1 and 1, that is minus sine 1. So whatever, this is also finite. So I have two regular point, 1 0 1 belongs to 0 pi by 2. So this value is equals to 2. Next problem is very nice problem. y1x be a non-trivial real valued solutions, and y double dash plus x yx is equal to 0. So 0, and y2x be the solutions of y double dash plus yx into x square plus 2. Plus 2. So y1x be the non-trivial real valued solutions. So whatever you see that y double dash plus y2x be the solution of this, plus y equal to x square plus 2. So this is m square plus 1 equals to 0. So I have to find out auxiliary equations. So auxiliary equations is y square plus m square plus 1. So the value is m equals to plus minus I. So it is c1 cos x plus c2 sin x. c2 sin x. And now whatever I have to find out, pi. Pi equals to 1 by d square plus 1 into x square plus 2, and this portion can be written this way: 1 minus d square plus d to the power 4 minus up to this into x square plus 2, and this value is x square plus 2, and derivative of x square plus 2 is 2. So this point cut, so I get x square. So my y is x is equal to yx, sorry, it is not yx equals to plus x square. You will get this value, and after that, friends, whatever they say, y0 is equal to 0 and y dash equals to 0. This is the boundary conditions. These boundary conditions hold. So y0 is equal to 0. So whatever I get, c1 equals to 0 and y dash 0 equals to 0. That implies c2 is equal to 0, friends. So my value y2x equals to x square. Very simple, friends. And y2x has x equals to 0, x equals to 0, order 2. Now, friends, for y1x, now I have to find out for y. So whatever I get y2x has finitely many 0. y2x has finitely many 0. Now for y1x. For y1x, Strum's fundamental I write fundamental comparison theorem. Comparison theorem. That formula I use. Strum fundamental comparison theorem. Let phi 1 be a real solution of ddx of px and dy by dx plus phi 1 x y x equals to 0. So in the question you see that y double dash x y double dash plus x y x equals to 0. This is my questions in the questions. So friends, in here I can write y double dash plus x y x in here equals to 0. So whatever you see ddx into 1 into dy by dx in this way plus x into yx equals to 0. Let p have a continuous derivative and be such that px greater than 0 and let phi 1 x and phi 2 x be continuous such that phi 2 x greater than phi 1 x then between two successive zeros of phi 1 there exists at least one zero of at least one zeros of phi 2 x. This is the strum comparisons theorem. Here you see that phi 2 x is equal to phi 2 x is equal to phi 2 x, and another factor that in here phi 1 x I consider phi 1 x is equal to is equal to 1. Now consider a real line and where 0 is a point and 1 is a closed interval. So 1 comma infinity, this point is 1. So 1 comma infinity obviously less than 0 comma infinity. We consider of y1 on 1 comma infinity, that implies x greater than 1, and in here phi 2x greater than phi 1x, and phi 1x, obviously phi 2x is equal to x and phi 1x equals to 1. So yx is equal to c1 cos x and c1 cos x plus c2 sin x if y double dash plus y equals to 0. This case when the phi 1x. So and there cos x and sin x is the base root and graph is like this. So our zeros are infinity because phi 1x zeros are infinity. So infinitely many zeros. y1x has infinitely many zeros. Now we will go to discuss next problem. Legendary differential 1 minus x square d square y divided by dx square 2x into dy dx plus 6y. So this problem is also very interesting problem. So 1 minus x square into d square y divided by dx square minus 2x into dy by dx plus 6 into y equals to 0. This is the Legendre polynomial. So Legendre polynomial that equals to can be written 1 minus x square d square y divided by dx square minus 2x into dy by dx plus 2 into 3 into y equals to 0. That implies n equals to, it can be written this way, 1 minus x square into d square y into dx square plus sorry, this is not plus, it is minus, this is this way, actually dy by dx into plus n into n plus 1. Okay, So friends, what is the value of n? N equals to 2, I get. And so that's why yx is equal to a0 y1x plus e2 e1 y2x, and Legendre polynomial y1x equals to one into n equals to 2, so 2 into 2 minus 1 divided by 2 factorial. Here n 2 equals to n into x square plus other term is 0. Similarly, it can be it is not plus, it is plus. So 1 minus 3 by 2 x square, friends. Simple, and y2x equals to x minus n into n minus 1 n plus 2 divided by 3 factorial into x cube plus n minus 3 into n minus 1 into n plus 2 n plus 4 divided by 5 factorial, because I have written the formula. What is the formula? So this is x to the power 5 up to infinity, however, whatever. So what is my result? Result is x minus 2 into 2 minus 1 plus 2 plus 2, so 4 by 3 x cube minus 1 by 5 x to the power 5. This is the up to infinity, whatever. So yx is equal to, what is my formula is a0 into 1 minus 3x plus a1 x minus 4 by 3 x cube 1 by 5 x to the power 5 up to infinity. So putting now y1 equals to 1, this is my condition. So whatever I get a0 2 into a0 minus 2 into a0 minus, so plus a1 1 minus 4 by 3 minus 1 by 5 equals to 1. So minus 2 into a0 minus 8 by 15 a1 equals to 1. This is one equations. So my adjusted value a0 equals to minus half and a1 equals to 0. So yx is equal to minus half into 1 minus 3x square divide by 3 by 2 x square minus half, and integration -1 to 1 yx into x plus x square dx equals to -1 to 1 3 by 2 x square minus half into x plus x square into dx. So that value is equals to 3 by 5 minus 1 by 3, and I get 4 by 15. This is my values. So friends, I do not multiply this formula, multiplication. If you will multiply, then whatever you get, -1 to 1, and another factor half is common. So whatever I get 3x to the power 4 minus x square into dx. So this is my answer. You can check it. And if any mistake, please tell me, because I am just learner and teaching. I like to create videos. That's why I create, and I enjoy with this. Thanks for watching.